それでは先ほどのボニー・バスラーの講演会に引き続いて、今度はサイエンスライターのエド・ヨン、彼が話をしている講演会のビデオをご紹介したいと思います。エド・ヨンはですね、今申しました通りサイエンスライターなんですけども、特にイギリスの BBC とかですね、またはイギリスの新聞のガーディアンという新聞がありますけども、そちらによくライターとして記事を書いているようです。そしてアメリカでもですね、タイムという雑誌がありますけれども、そのタイムでも記事を書いています。でさらにですね、さらにと言いますか、エド・ヨンという彼の名前を一躍有名にしたのがですね、アメリカのナショナルジオグラフィック社、ナショナルジオグラフィックという、雑誌がありますけども、そのナショナルジオグラフィック社のですね、サイト、ホームページで彼がですね、ブログを書いてるんですね。ブログを持ってるわけです。そのブログでの記事が非常に有名になりまして、彼の活躍がですね、ジオグラフィック社のそのブログで有名になったということもあって、サイエンスライターとしての地位をですね、確立したようですね。非常にですね、これからエド・ヨンのその話をあなたにご紹介しますけどもね、講演会の内容をご紹介しますけども、非常に分かりやすいです。で、メリハリの効いた解説で、非常に優しい言葉で私たちに解説をしてくれています。題名に書いてある通り、生物の陰に潜む寄生生物の影響力についてという、こういうテーマなんですけども、実際の彼のこの講演会でのテーマは、上に書いてあるこの英字がテーマになっています。そのまま訳すと非常にビビると言いますかね、怖がる女性も多いかと思いますので、ダイレクトには訳しません。いずれにしましてもですね、彼の話は非常に興味深く、そして身近な話題、テーマでもありますので、私たちも非常に納得すると言いますか、もちろん彼の講演会の内容を聞くあなたもですね、非常に理解の進むと言いますか、納得のいく講演会の内容になっています。先ほどね、あなたにご紹介したボニー・バスラーの場合は、コーラムセンシングという言葉を使いながら、一粒一粒の細菌がどのようにコミュニケーションとして、そして、他のね、細菌とも共通言語を使いながら、お互いね、コロニーを形成しながら共生しているというね、そういう話でしたけれども、このサイエンスライターのエド・ヨンの話は、一粒の細菌にも触れますけれども、それよりもですね、いわゆる一粒の寄生生物、一粒と言いますか、えげつない言い方すると、一匹のですね、えげつないというか分かりやすい表現を使うと、一匹の寄生生物がどのように振る舞うのかと、そこにフォーカスしながら話をしてくれています。ですから、非常にある意味私たちにとっては、馴染みがあると言いますか、そういうことだろうなというふうにですね、合点のいく話ばかりです。そして彼の講演を最後まで聞いていただければ、ボニー・バスラーの話も含めてですね、私たちが今日まで研究しているその細胞内感染という意味もより深く理解できるかと思います。それではですね、早速サイエンスライターエド・ヨンの講演会の内容を一緒に聞いてみましょう。
A herd of wildebeest, a shoal of fish, a flock of birds. Many animals gather in large groups that are among the most wonderful spectacles in the natural world. Why do these groups form? The common answers include things like seeking safety in numbers, or hunting in packs, or gathering to mate or breed. And all of these explanations, while often true, make a huge assumption about animal behaviour, that the animals are in control of their own actions, that they are in charge of their bodies. And that is often not the case. This is Artemia, a brine shrimp. You probably know it better as a sea monkey. It's small and it typically lives alone, but it can gather in these large red swarms that span for meters. And these form because of a parasite. These shrimp are infected with a tapeworm. A tapeworm is effectively a long living gut with genitals at one end and a hooked mouth at the other. As a freelance journalist, I sympathise. The tapeworm drains nutrients from Artemia's body, but it also does other things. It castrates them. It changes their colour from transparent to bright red. It makes them live longer. And, as biologist Nicholas Rode has found, it makes them swim in groups. Why? Because the tapeworm, like many other parasites, has a complicated life cycle involving many different hosts. The shrimp are just one step on its journey. Its ultimate destination is this, the greater flamingo. Only in a flamingo can the tapeworm reproduce, so to get there, it manipulates its shrimp hosts into forming these conspicuous coloured swarms that are easier for a flamingo to spot and to devour. And that is the secret of the Artemia swarm. They aren't sociable through their own volition, but because they are being controlled. It's not safety in numbers, it's actually the exact opposite. The tapeworm hijacks their brains and their bodies, turning them into vehicles for getting itself into a flamingo. And here is another example of a parasitic manipulation. This is a suicidal cricket. This cricket swallowed the larva of a Gordian worm, or horsehair worm. The worm grew to adult size within it, but it needs to get into water in order to mate. And it does that by releasing proteins that addle the cricket's brain, causing it to behave erratically. When the cricket nears a body of water, such as this swimming pool, it jumps in and drowns, and the worm wriggles out of its suicidal corpse. Crickets are really roomy, who knew? The tapeworm and the Gordian worm are not alone. They are part of an entire cavalcade of mind-controlling parasites, of fungi and viruses and worms and insects and more that all specialize in subverting and overriding the wills of their hosts. Now, I first learned about this way of life through David Attenborough's Trials of Life about 20 years ago, and then later through a wonderful book called Parasite Rex by my friend Carl Zimmer. And I've been writing about these creatures ever since. Few topics in biology enthrall me more. It's like the parasites have subverted my own brain. Because after all, they are always compelling, and they are delightfully macabre. When you write about parasites, your lexicon swells with phrases like devoured alive and bursts out of its body. But there's more to it than that. I'm a writer, and fellow writers in the audience will know that we love stories. Parasites invite us to resist the allure of obvious stories. Their world is one of plot twists and unexpected explanations. Why, for example, does this caterpillar start violently thrashing about when another insect gets close to it and those white cocoons that it seems to be standing guard over? Is it maybe protecting its siblings? No. This caterpillar was attacked by a parasitic wasp which laid eggs inside it. The eggs hatched and the young wasp devoured the caterpillar alive before bursting out of its body. See what I mean? Now, the caterpillar didn't die. Some of the wasps seemed to stay behind and controlled it into defending their siblings, which are metamorphosing into adults within those cocoons. This caterpillar is a head-banging zombie bodyguard defending the offspring of the creature that killed it. We have a lot to get through. I only have 13 minutes. Now, some of you are probably just desperately clawing for some solace in the idea that these things are oddities of the natural world, that they are outliers. And that point of view is understandable because by their nature, parasites are quite small and they spend a lot of time inside the bodies of other things. They're easy to overlook, but that doesn't mean that they are unimportant. A few years back, a man called Kevin Lafferty took a group of scientists into 3 Californian estuaries, and they pretty much weighed and dissected and recorded everything they could find. And what they found were parasites in extreme abundance. Especially common were trematodes, tiny worms that specialize in castrating their hosts, like this unfortunate snail. Now, a single trematode is tiny, microscopic, but collectively they weighed as much as all the fish in the estuaries and 3 to 9 times more than all the birds. And remember the Gordian worm that I showed you, the cricket thing? One Japanese scientist called Takuya Soto found that in one stream, these things drive so many crickets and grasshoppers into the water that the drowned insects make up some 60% of the diet of local trout. Manipulation is not an oddity. It is a critical and common part of the world around us. And scientists have now found hundreds of examples of such manipulators.